Okay, we're going to be working with exponential functions. Now, that function is written as y equals a times b to the x power. First off, we know that x is our independent variable. We know y is our dependent variable. Okay? When we're dealing with exponential growth and decay, most of the time, that independent variable is going to be time, whether it's numbers of weeks, days, minutes, whatever. What did we call the b? The base. What else was it? That wasn't the initial. This is the amount that it grows. We're going to call it the rate of change, right? Now this one right here, now this one is the what? It's the initial amount, starting point, or whatever. Like, for example, if you're talking about bacteria, it's the amount of bacteria you're starting with. You're talking about frog population. It's how many frogs you start with, okay, in a pond. Now, if I wanted to talk about growth, okay, if I wanted to talk about growth, this number right here is going to be larger than 1. Well, give me the type of phrases that we used on when we did one of our other assignments. Like, what was, when they talked about somebody's pay, what were they doing to the pay each week? They were doubling it. What is double? What number is double? 2. Triple, right? 3 times. We also put in there those percentages, right? We put in there like 3%, it goes up, or it grows by 3%. That number went in there. This number was always what we started with. Like with population, it was 17 million. This is what did you start with? Okay. If there's, say I had, well, no, I'll do that in just a minute on the next one. Okay, so this right here is growth. Now, if I was talking about decay, y equals abx, what type of numbers would this be? They'd be a fraction, but it'd be more specifically, it's a fraction. It's a number between 0 and 1. Okay? Because it has to be less than 1. It's got to make this go down. So, for example, we could have in there 1/2. This is in science, we call it a half. One of the things we use is a half-life. Okay? It could be 1/3, 1/8. How is it going down? Okay? This also could be, it could be a percentage as well, but it would be something that you are reducing, right? Say that it's decreasing by like depreciation. A car. When you drive a car off of a lot, your car depreciates by a certain percentage. Okay? We didn't get as much into this the other day, and hopefully I'll put more of these online that where I'm able to do that today that shows you the decay. All right, so what we needed to do here, oh, nope, that does have the decay, but let's go back here for a second. All right, what we needed to do was we were supposed to look at these and say, okay, I need to put this in the calculator. Oh, where'd my pen go? There we go. Put this in the calculator, and I wanted us to see what happened. First off, with y1, what number is the rate of change? It is a 2. Now, y'all, I said that it was y equals a times bx. B is 2. There's not a number sitting there in front of the 2 for that a, for that initial starting point. What is that number if there's not a number there? It's a 1. Okay, so let's see. When you went in the calculator and went and looked, let's see here, go in y1, and I put in there 2 to the x power, and I press graph. That's what it looks like. It asks you to find the X and the Y-intercepts. Well, when I went into the table, the Y-intercept, let's see here. Well, come on, little machine here. Here's my Y-intercept, 0 what? 0, 1. Okay, let's see. 0, 1. And then you went and looked, and I'm looking for the X-intercepts. I'm looking to see where Y is 0. Remember? So as I look through my table right here, and I'm looking, what's happening to these numbers? What's happening to the Y numbers? They're decreasing. They're getting closer and closer. Look at your graph. They're getting closer and closer to 0. But if you continue on through that table, you're going to find out it never hits 0. It just gets really, 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 really close. So the X-intercept, there is none. Because, okay, so there is none. It just keeps going. I'm not going to go into it. Basically, the X-intercept is what's called an asymptote. Okay? The next one right here, what is the rate of change? 5. And when you put that in the calculator again, you go in here and you put 5 to the X power. Why is this being weird? Maybe let's just try and clear it all. There we go. 5 caret X. And then you press graph. Let's look at that. Now, is that one steeper or flatter than the 2X? It is steeper. It's steeper. What is making it be steeper? What in the equation is making it steeper? The 5 is. The 5 is bigger than 2. So it's making it increase faster. Well, first off, I should have gone over here. There we go. Y-intercept is 0, 1. All right, come on, machine. Here we go. And again, there is none when you go through and look at it. So let's see. The first one, where I have my rate of change of 2X, it started here. It kind of went close down here to 0. And it went up. You could do this. Now, the one with the 5 on it, it still started right there at 1, but it increased steeper. So I'm having a hard time drawing here on this board. Okay, now 1.5 to the X power. Is 1.5 bigger or smaller than 2? Smaller. So what do you think it's going to do to the line compared to the 2X? It's going to be less steep. It's not going to be up there by the green one, is it? Okay. When we put this in the calculator, you would find that, again, the rate of change is 1.5. The Y-intercept is 0, 1 because that's your starting point, that Y-intercept. Okay? This one is still going to curve, but it's not going to curve as much. Okay? Again, there is no X-intercept because it doesn't touch the X-axis. When I go through, first off, what is 7 divided by 2? 3.5 X. Okay, so my rate of change, you can either write 7 over 2 or 3.5. When you put that in the calculator, you're going to find your starting point is still 0, 1. Now, and there is no X-intercept, but when we go to put this in the calculator, which one of these lines does it go between? The red, blue, or green? Between the blue and the green. So it's between the 2 and the 5. And I probably didn't write that. The 5 should have been steeper, but, you know, I'm just such a good drawer right here. It goes in between it. Yes. Yes. Yes, you can put 7 over 2 and 3.5. But if you put 7 over 2, you must put it in parentheses in the calculator. That'll make a difference. So yes, when you put this in there, you have to press parentheses 7, divide 2 parentheses, caret whoops, to the x power. If you don't, it will put the exponent with the 2. Yes, it'll make it all crazy if you don't put that in parentheses. Is this growth or decay? Growth means it goes up. Is my line from left to right going up? Yes, this is growth. Okay? The next one. Right here, when I go, first off, y equals 1/2 x. This 1/2 is my rate of change. Okay? There's supposed to be a number here that is your initial value. What is that number? If there's not a number there, the initial value, oh well, whatever you guys, is 1. Okay? So my rate of change on the first one is 1/2. If you go in the calculator like we have been, now this is where we were talking about the parentheses. You've got to go in there and put 1 divide 2 in parentheses, caret to the x power. Now we can look at this graph. Look at this one. It's going down. It's going to be decay. Now, what is the y-intercept? The y-intercept right here is 0, 1. That's your starting point right here. 0, 1. Oop, let's see here. Okay? Now, when I go to look at, where's the calculator? When you go to find the x-intercept, this time, because it's decay, you're looking down this way, and it keeps getting smaller and smaller and smaller and going closer to 0, but it never touches. So, come on, pen. This right here is none. All right, so now, I'm going to draw my line. It's not quite touching there. 1/2, I'm going to go up. It would be better if I had more exact points, but we'll estimate right now. Then go into 1/4. First off, my rate of change is 1/4. What are you thinking the y-intercept is? I bet it's 0, 1. Because I said, do you guys understand the y-intercept? You should see that this is beginning, that the y-intercept is your initial value. Okay, so there's 1/4. Maybe I need to compare it. We'll go in here for a second. First off, the y-intercept is 0, 1 again. And there's going to be none. But I want to compare this because I'm not sure about sketching my graph. Let's compare this to the 1/2. Whoop, wrong button. There we go. So I'm going to go in here. Oh my goodness gracious. Here we go. I already have 1/4 x in there. Let me go down here and I'm going to put back in the 1/2. Now, to be able to tell the difference in my line, I'm going to go all the way over in the calculator to that little blinky thing, or the thing that's blinking right now, and press enter. It'll make the 1/2 a thicker line. So here's the 1/4, the 1/2. Okay, what do you notice about the 1/4 compared to the 1/2? Remember, the 1/2 is the big line. Is the 1/4, is it steeper or flatter? It's the 1/4 is that thin one. It is steeper. Okay, so now I'm going to go in here and I'm going to sketch it. They both start at 1, but it's steeper, so I'm going to draw it in here. Okay, now let's go in here to the 1/10. If I go into the 1/10, oh, let's see. I'm going to put 1/10. Oh, did that do funny things again? Hopefully it'll work here. Ooh, what's happening to the 1/10? It's even steeper. Now, let's see. I bet we're looking to see. I bet my y-intercept, it's 0, 1. So right here, my rate of change is 1/10. My y-intercept is 0, 1, and there is none here because it just gets closer. The y-intercept is the initial starting place, the initial number. That's what's going on right here. All right, so 1/10, I still start at 1, but I'm really steep right here. Okay? Remember, 1/10 is the same as 0.1. 1/4 is 0.25. 1/2 is 0.5. See how it's getting, these decimals are getting smaller? The smaller they are, the steeper they're getting. Now, what is 4 divided by 5? If you put 4 divided by 5, you should get 0.8. Okay, so wait, is 0.8 bigger or smaller than 0.5? Bigger. What do you think is going to happen? What is my line going to look like? Is it going to be steeper or flatter than the 1/2? It is going to be flatter because of the number. So it's going to come out this way more. And I'm going to have 4/5, 0, 1, and none. Okay, so here's what you need to start seeing. The y-intercept is going to be that initial number, that y equals ABX. That's going to be this one right there. Okay, this is going to be your y-intercept. This number right here is your rate of change. Now, let's look at the next one. This one, if you look at these, first off, on the first one, what is the rate of change? It is 2. Looking at it, what can we already tell is the y-intercept? What number is in front of this? Yeah, it's a 1. Y equals 1 times 2 to the x power. The y-intercept is 0, 1. You're going to put that in the calculator. You're going to see that there is no x-intercept. So we already graphed this one once. So it went here, and I went up. That's not right, is it? I went down. Try again. Because that 2 is bigger than 1, so it's got to be growth. Sorry, let me sketch that in the right. Good drawing, Crawford. All right. What about this one? What is my rate of change? It is 2. Remember, it's whatever the base is. What is my y-intercept going to be? 0, 3. And there is none. There is no x-intercept. So let's look at this for a second. Let's go in here and put, let me get all this cleared out here. Let's put 2 caret x, and then I'm going to make that my dark line. Enter. So now I'm going to go down here. Oop. I'm going to put in there 3 times 2 caret x. Make sure you put that right there in parentheses. And let's look at them. There's the 2x. And then there's the next one. Why did that make 2 dark lines? I didn't want it to be dark lines. I go back. It made it a dark line. I wanted to see the difference. There we go. All right, there's my original, the 2x. The 3, it looks like it's steeper, but the rate of change is the same. What's the only thing that's different? The y-intercept. See, my y-intercept, instead of 1, it's 3. But everything else, the amount of change, look at these numbers. If you take 0.5 times 3, what do you get? 1.5, right? 0.25 times 3? 4 times 3 is 12. Okay, so we have this one. Now, let's see. So it actually was the same steepness, but it just started at 3. So unfortunately I can't draw, but it's the same steepness. So it should mirror each other. It really should be translated. If I made a nice line, like a curve like this, all I'd actually be doing is translating and moving up the y-intercept. Now what happens here? What is the rate of change on this next one, on y3? Rate of change is still 2, so that means that the curve is actually the same steepness. But what is this? What is it? The y-intercept. So you could write it as 0.5, 0, and then comma 0.5. This is still none. Oh, I used the wrong color on this one. Oh, well. Let's see. Let me try and change the color on this. Oh, let me. There we go. All right, so the blue was starting at 1, yada, yada. Yep. The green was starting at 0.3, or not 0.3, starting at 3. Where is the red going to start at? 0.5, right here. Same steepness. What's going to happen to this? What's the rate of change? 2. Steepness is the same. What's my starting point? 10. There's still no y-intercept. So my starting point would be up here at 10. Okay? So this number in front is my starting point. This number right here is the steepness of my line, that base, that rate of change. Okay? This one said a biologist noticed that the population of ladybugs in a sample doubled every 3 days. If the initial sample had 30 ladybugs, what was the population of ladybugs at the end of 3 days? I'm sorry, the end of 9 days. You know I have y equals ABX. Woo, let's write the X in the right spot. Okay, y equals, what's the initial amount of ladybugs I have? 30. So that goes there. That's my starting point. Times, what is my rate of change? It's doubled. That's my rate of change. It's 2, but I need to know what the exponent is. Be careful. It doubles every 3 days. So 3, 6, 9 days. 1, 2, 3. You're actually going to take it to the 3rd power. It doubles every 3 days. So now when you put that in the calculator, if you haven't done it, do that now. 30 times 2 to the carrot of 3. 2 times 2 is 4. 4 times 2 is 8. So it should be 200. Did you get 240? Okay. Put it in the calculator. Put 30 times 2 carrot 3. The next one. All right, so I have my y equals ABX. The radioactive isotope carbon-11 is used in medicine for brain scan procedures. It decays, so that means my answer is going to be going down, by losing half its mass every 20 minutes. If a doctor checks on a patient 2 hours after the isotope has been administered and 10 micromilligram of it still remains, which is the closest amount of isotope carbon-11 administered to the patient. Woo! That's a whole lot of words right there. Okay. This is how much remains. Okay? This is the time. This is the initial amount. We're trying to find the initial amount. We're trying to find this right here. Okay? So first off, it says that there's 0.10 still remaining. 0.10 still remains. I'm trying to find this amount. How is it changing? So the rate of change, half every 20 minutes. But the time is not 20. How are you getting 6? How many 20-minute intervals are there in 2 hours? Every hour, it's 20, 40, 60. Okay, so every hour, for every hour, there are 3 20-minute periods. So this would be to the 6th power in 2 hours. Now, oh man, what do we do here? Okay, so we have 0.10 equals A times, would you please put in your calculator 1/2 caret 6? What is that? Let's see here. We have 1/2, oh, I forgot my parentheses. 1 divide 2 caret 6. Now press math, enter, enter. What does that say? 1 over, good, because I'm blind. Okay. Oh, what'd you do here? All right, 1 over 64. So this becomes 1 over 64. What you do to find your answer here is, this is the same as saying 0.10 equals A over 64. You are actually going to multiply both sides by 64. These cancel out. What is 64 times 0.1? So what is it closest to? Yep, F.